So now we are going to discuss about the Banker's algorithm. So it is also used for deadlock avoidance. So previous video we have discussed about the resource allocation graph algorithm. It is only used for the resource with only one instance. If resources having multiple instances, the resource allocation graph algorithm is not applicable. So for resources with multiple instances, we are using the Banker's algorithm. So in Banker's algorithms also, if new thread enters, it declares the maximum number of instances of each resources it need. So it need to be declared while the thread enters itself. Okay. Then for that, so we need some data structures. One is that there are four things. One is available. Consider the vector of length. Consider the vector of length m. So the available j is equal to I. It means that the resource Rj with k instances. Okay, for resource Rj, k instances are available. Then max of I comma j is equal to 0. It means that for thread ti request maximum of k instances of resource Rj. So the thread ti request Rj with maximum of k instances. The third one is the allocation. It is a n cross m matrix. So here if allocation of I comma j is equal to k, it means that for thread ti, k instance of resource Rj has been currently allocated. K instance of resource Rj has been currently allocated. Okay. Now need, it is also n cross m matrix. So the need of I comma j is equal to k. It means that the thread ti may need k instance of resource Rj. So always if the max and allocation has been given for a particular thread, we can calculate the need. So the maximum, it is the thread needs these many resources for complete its execution. So from this needed maximum, so this has been allocated already. Okay. So if you subtract that allocated from that max, so we can find the currently need. I mean, still how many resources we need to allocate, or till how many resources the thread need to complete its execution, that we can calculate. Okay. Now, first we go with the safety algorithm. Okay. So, consider, let work and finish be the vectors of length m and n. Okay. Then initialize the work is equal to available, and so and finish I is equal to false. Initially, none of the threads have been finished completed its execution. So we initialize the finish of I is equal to false. So now find an I such that both it's not completed. Okay, it's not completed its execution. That is finish of I is not equal to false. Then need I is less than or equal to work. The work is the available. So the current need is less than or equal to work. Then the particular resource can start its execution. Okay. Then see, if we find that the particular thread which is not completed, and the current need of the thread is less than the currently available resources. So what you need to do, we need to allocate that requested resources for that thread. So after while you have allocated, you need to change the available is equal to, so already available plus currently what, how much resources instance of resources we are allocating, that we need to add, and then we have to update that current available. Okay. So then once it has been completed, so you have to finish of I is equal to true. The thread has been completed its execution. Once all the thread completes, so it means that the thread of all finish of all the I is equal to true. So once all the thread has been completed its execution, the system is in a safe state. If any thread is not able to complete its execution, the system is not in a safe state. Okay, so we need the order of m into n squared operations to find whether the system is in safe state or not. Okay, then we go with the resource request algorithm. So the resource request algorithm determining whether the request can be safely granted. Now let request I be the request vector for thread Ti. Okay. Now if request of I, that is of j is equal to day, then it means that the thread Ti wants k instance of resource Rj. If the request is less than need, then go to step 2. Otherwise, because to complete its execution, the thread Ti may need 10 resources, but it is requesting more than greater than, then there will be a error. Okay. Then if it is less, then go to the step 2. So the request of I is less than available. We cannot less than available. Definitely we can allocate that particular resources to the thread. Okay. So otherwise, if the request is available, it need to wait till the request amount of resources are available. Okay. Now we have allocated, then we have to update this 3. Available is equal to available minus request, because we have been allocated those many resources. So we need to subtract that from the available resources. Then allocation is equal to allocation plus request. For example, already 3 resources has been allocated to a thread Ti. Now it's requesting 3, it has been allocated, means now you have to totally 6 has been allocated to a thread Ti. Okay, then the need minus request, the maximum need is 10. Okay, so already 6 has been allocated, so the 10 minus 6 we need to keep, so remaining need is 4. To calculate that, so need is equal to need of thread I minus request of thread I. This is the resource request algorithm. If the resulting resource allocation state is safe, the transaction will be completed. Otherwise, it will be in a waiting state. Okay. Okay. Thank you.